We, Lakshmanjali and Haripriya, students of GRIT Biotechnology, has done a project on Fourier transform infrared spectroscopy, that is FTIR. FTIR works on the principle of the infrared source that emits a broad band of different wavelength of infrared radiation. The IR radiation goes through an interferometer that modulates the infrared radiation. The interferometer performs an optical inverse Fourier transform on entering IR radiation. The modulated IR beam passes through the gas sample, where it is absorbed to various extents at different wavelengths by the various sample molecules present. Finally, the intensity of IR beam is detected by a detector. Components of FTIR are source, Michelson interferometer, sample, and detector. Coming to the source, infrared energy is emitted from a glowing black body. This beam passes through an aperture which controls the amount of energy presented to the sample. Michelson interferometer. The components of Michelson interferometer are beam splitter, stationary mirror, moving mirror at constant velocity, motor-driven micrometer screw, helium neon laser, sampling interval control mirror velocity. Michelson interferometer works on basis of beam splitter for dividing the incoming IR beam into two parts. Two plane mirrors for reflecting the two beams back to the beam splitter where they interfere either constructively or destructively depending on the position of the moving mirror. When moving mirror is in the original position, the two paths are identical and interference is constructive. When the moving mirror moves 1/4 of wavelength and path difference is half wavelength and interference is destructive. Mirror moves back and forth at constant velocity. The intensity of interference signal varies as a sine wave. The beam after interference passes through the sample. Coming to sample preparation, sample is in the form of pellet and is prepared by mixing the sample powder with KBR in a mortar. Later, by placing the powder in KBR press along with sample holder and by applying 10 tons of pressure, sample pellet is formed. The pellet formed is placed on the sample compartment of FTIR. The beam enters the sample compartment where it is transmitted through or reflected off of the surface of the sample, depending on the type of analysis being accomplished. This is where specific frequencies of energy, which are uniquely characteristic of the sample, are absorbed. The beam then finally passes to the detector for final measurement. The detectors used are specially designed to measure the special interferogram signal. Here, it is Digitech detector system with integrated true 24-bit dynamic range ADC, which is high sensitive to room temperature. Then, measured signal is digitized and sent to the computer with the Fourier transformation takes place. The final infrared spectrum is then presented to the user for interpretation and further manipulation on IR spectrum window, because there needs to be a relative scale for the absorption intensity. A background spectrum must also be measured. This is normally a measurement with no sample in the beam. This can be compared to the measurement with a sample in the beam to determine the percent transmittance. This technique results in a spectrum which has all of the instrumental characteristics removed. Thus, all spectral features which are present are strictly due to the sample. A single background measurement can be used for many sample measurements because the spectrum is a characteristic of the instrument itself. So, the detected signal is digitized and further transformed by the computer to get the IR spectrum of the sample gas. The resulting spectrum is the characteristic of organic molecules present in the sample. So, we can know the compounds present in the unknown sample. So, this is how an FTIR works. Thank you.